Hello student, today I'm going to discuss with you this problem. It is already in the notes that I have solved, but I think most of you will not understand it that much, how we resolve the forces along and perpendicular. Okay, though though it is correct only, but I just want to explain it in detail. Okay, how we got there, values of those, how we calculate the decrease of these forces with respect to the x-axis. So the question is forces equal to 3P, 7P and 5P acts along the side AB, BC, CA taken in order, okay, of an equilateral triangle ABC. Find the magnitude, direction and the line of action of the resultant of all these three forces acting along an equilateral triangle. So here you draw here this ABC, okay, is an equilateral triangle. Okay, I'll show it here. This is an equilateral triangle in which all the three sides are equal and the angle of each, the angle here, angle A, angle B and angle C, they are equal and each equal to 60 degree. So if you draw here, this one, extend this AB along the x-axis, okay, it is horizontal. So here it is 60 and we know that this whole angle here, it is 180 degrees. So what will be this angle? It will be 120 degree. Now similarly here you have 60 degree, but the whole angle, this one, okay, this will give you 180 degree. So whereas this much gives you 120 degree, because 60 plus 30 plus another 90 gives you 120. Okay, not this part 30 degrees this, and then from here to here is 90, so you get 120 degree. So here in this problem, okay, you have this triangle ABC, 60 degree, this is 3P, okay, yeah, 3P, 5P, 7P, I mean 7P and 5P. So here what we do is we have to find the magnitude of these forces. So this is space diagram, okay, we assume in space, okay, these forces. Now you draw the reference or the force diagram here. Draw any line here now parallel to this one, okay. First draw any line parallel to AB, that is this one. You take it as O, okay, this is OX. And then draw another line parallel to this force 7P acting along BC. So this force, this line should be parallel. This is force 7P. So here as you can see, if you extend it to this, okay, so this angle is 60 degree. So here also it should be 60 because these two lines are parallel. So this angle here now will be 120 degree. Now as you can see here in the direction of the force, this is 3P. Now along this, if you extend these forces, okay, downward, because it is moving downwards, so draw another line parallel to this AC. So here, so this is force 5P, okay. So what will be the angle here? The angle made by this line with respect to the x-axis. With respect to the x-axis here, for this one, okay, it should from here to here 120, and here this part on, I mean this part only along with this horizontal line, it will be 60 degree. Now here also it will be 120 degree. So here also it will be 60. So in general you have here, okay, I'll just draw it roughly. This is, sorry, it is not this one exactly. Oh, sorry, it should not be perpendicular, it is this diagram. So here you have 120 degree, here you have 120 degree, and here also 120 degree. This is force 3P and this is force 7P and this is force 5P. Now resolving these forces, take this as origin OX as the x-axis. So by resolving these forces along the x-axis, so you see in this, so we resolve here, We take A as the origin and AB as the x-axis, the line through A and perpendicular to AB as the y-axis. So now resolve all the forces along AX. So that is x here is sum of the result part of the forces along the x-axis, along this one. Okay, so we have how many forces are there? You have 3p, 7p and 5p. So since this force 3p is along the x-axis only, so the degree of this will be equal to 3p cos 0 degree, and then plus 7p, it is this angle. If you draw here, this is the force space diagram. So here this force is here it is 120 with respect to the x-axis. So here you have 7p plus 7p into cos of 120 degree, and then plus. For this force, if you move it downwards, what are the angle made by this line with reference to the x-axis? Here you have 120. As you can see in this figure, how we get 120, 120, 120. You draw a horizontal line along this. So we have here, this is 120, 120. So the motion of the degree here will be, that is 5p into cos of 240 degree. 240 degree with respect to the x-axis. So we have cos of 240. But what we have here is that what is 7p? 7p is a cos of 120 is minus cos of 60 degree. And what is cos of 60 degree? It is 1 by root 2. So you have minus sign here. And what is cos of 240 degree? Again, it is cos of minus cos of 60 degree. That is minus 5p into 1 by root 2. So this, you sum up this, you will get minus 3p. That is the result part of all the forces along the x-axis. Now similarly, the result part of the forces along the y-axis, that is capital Y, we denote it by summation of y1. As in the analytical method, we have y1 is p1 sine alpha 1 plus p2 sine alpha 2. So we have 3p sine 0 degree plus 7p sine 120 degree plus 13p. Okay, sine of 240 degree. But sine 0 is 0. 7p into sine of 120, it is root 3 by 2. Whereas sine of 240 degree gives you minus root 3 by 2. So you have minus 13p into root 3 by 2 is equal to root 3p. So this whole thing gives you root 3p. That is the result part of the forces along the y-axis. Now we have to find the magnitude of the resultant force. We know that R is equal to square root of x square plus y square. You replace x by this value minus 3p the whole square, so you'll get 9p square, and replace this capital Y by root 3p. It will be 3p square, so you have square root of 12p square. So square root of 12 gives you 2 root 3 into p. So therefore the resultant R is 2 root 3 by p. And what is the direction of the resultant force? The direction of the resultant force is given by theta, which is equal to tan inverse of y by x. You know what is the value of y? Y is root 3p. And what is the value of x? It is 3 minus 3p. So it will be, okay, sorry, I didn't solve it here. So you have here y tan inverse of root 3p divided minus 3p. P cancel. Root 3 by 3 gives you tan inverse of minus 1 by root 3. Theta here, or theta is equal to this. Or you can say that theta here is equal to tan inverse of minus 1 by root 3 is nothing but tan inverse of 150 degree, or theta here is equal to 150 degree, because minus tan inverse, you apply tan theta here, tan theta will give you minus 1 by root 3. And for what value of theta it gives you tan theta is equal to minus 1 by root 3? It is for theta is equal to, so this implies that tan theta is equal to tan of 150 degree. Okay, so implies that theta is equal to 150. Tan of 150 can be written as tan of 180 minus 30 degree. And this is nothing from trigonometry. Tan of pi minus theta gives you minus tan theta. Using this result, we have tan of 150 degree is equal to minus tan of 30 degree. So we have theta is equal to 150 degree. Next, we have to show the algebraic sum of the moment. We have to find out G in order to find the equation of the line of action of the resultant. So as in the figure, as you can see in the figure here, these two forces 5p and 3p, if you take the moments of the forces about this point A, we consider A as the origin, and since these two forces are passing through this point A, their moment about this point A will be equal to 0. That is, the moment of force 5p about A will be 0. The moment of this force 3p about A will be 0. Why? Because it is the product of force into its perpendicular distance from here. But since this force is passing through A itself, so therefore it is 3p into 0, 5p in 0. So remaining is 7p into its perpendicular distance. So you draw here AN is the perpendicular distance to the side BC. And moreover, since it is an equilateral, this perpendicular divides BC into two equal parts. That is, BN is equal to half of AC. Now from here you consider this right angle triangle ABN, right angle at N, and by Pythagoras theorem, AB square is equal to BN square plus AN square. What is AB? AB, the length, let us denote it to be A, the length of this side of an equilateral. And BN here is equal to half of BC, so it will be half of BN is equal to half of BC. So you have AN square is equal to AB square minus BN square, and AB, the side of a square, it is equal to A square, minus BN, it is A by 2, that is half of BC, so it will A by 2 the whole square. So this gives AN is equal to root 3 by 2 into A. So once you get the value of AN, that is root 3 by 2 into A, you substitute in G. What is G? G is the sum of the moments of the algebraic sum of the moments of all the forces about A, and we know that the moments of the force 3p about A will give you 0. That is 3p into 0 plus 5p into 0, whereas AN is 7p into its perpendicular distance from this point A. So we have got the value of AN to be root 3 by 2 into A, 7p into root 3 by 2 into A. Substitute it in the equation of the line of action. What is the value? G equal to xy minus yx. We have got the value of y, we know the value of x, and also we have got the value of G. So replace it, substitute it here. So we have here the equation of the line of action is 2x plus 2 root 3y minus 7a is equal to 0. I think in the notes I miss this a, okay, but you just correct it. It should be 7a, where a is a side of an equilateral triangle.